Today we're going to dive deeper into the mole-to-mass relationship, and we're going to bring it into stoichiometry. So what you'll need for today's notes is a periodic table, a calculator, a writing utensil, your map of Moleville, and your follow-along notes. So remember that since the molar mass of a substance is the amount of mass, or the grams in 1 mole, those two are equivalent, so you can use it as a conversion factor. So you can have 1 mole equal to its molar mass, or set as a ratio to its molar mass, or you can have molar mass compared to 1 mole. Remember, on each side of these, you need NUF, number, unit, formula. So like up here, this says 1 mole, but 1 mole of what? Make sure you put your formula. And right now we're staying within the same formula within a problem, so that seems kind of obvious, but starting next chapter, we're going to add different formulas and we're going to convert using your balanced chemical equation. So if you're just used to writing NUF for everything, number, unit, formula, so every part of this has 3 parts, then it'll make your life a lot easier. All right, so grab your map of Moleville. This is what it looks like so far, and we're going to add to it. So we have one other part, and that is going to be mass mansions. So mass mansions is up in the top left. You're going to need a road to connect those two. And just like I said before, make sure you write the stuff that you need on the road in the right location. So right outside of Mole City Hall, they're going to have written on the road 1 mole. And you know that when it talks about mass, the mass of 1 mole is going to be equal to the molar mass. So 1 mole and molar mass would be next to mass mansions. You do have another stop sign, and this says BFF. Why does it say BFF? Because your periodic table is your chemistry BIF. So your best friend in chemistry, periodic table, all the answers for this are already there on your periodic table. The unit for mass mansions, or the only kind of house you can buy there, is the grams. So we've got our units, grams, and moles. And now we can see there is going to eventually be a relationship between these two, but for today we're just going to focus on how to use this road. Same rules apply. The first thing you hit on the road is what you divide by, and then after that you multiply in your conversion factor. So let's try one. What is the mass of 6.3 moles of a sample of potassium oxide? All right, so the question is, what is the mass? And we have 6.3 moles. So we're starting with moles, and we're going to grams, because grams is our unit of mass. So here's the direction we're going to take in Moleville. We're going to go from Mole City Hall, because we're starting with 6.3 moles. We're going to mass, so that goes this way, and remember the unit for that will be grams. We first need to figure out the formula for potassium oxide, because potassium oxide is going to have its own molar mass based on its formula. So I know that the charges of potassium and oxygen are K+ and oxygen 2-. How did I get that? Well, I don't see any prefixes. Plus, I see that potassium is a metal, so I know that this is going to be ionic, and ionic things have charges. Potassium has 1 valence electron, so it'll lose that 1 valence electron. When you lose, you become positive, so I lost 1, so it's positive 1. Oxygen is on the periodic table in row 6A, or 16, so it has 6 valence electrons, so oxygen will gain 2, and when you gain, you become negative, so negative 2. Well, these obviously aren't equal and opposite. I need 2 potassiums to cancel out my negative 2 charge from oxygen, so it's K2O. Now I need to find the molar mass of this, because I'm going to use that, so I might as well do this mass before I get into any of my other calculations. So I have 2 times 39.1, because that's the mass of potassium, plus 16. This is 49.2 grams. All right, so now let's do our stoichiometry. Always write your known first. So here is your known, 6.3 moles of potassium oxide. And then once you have your known, X line. So we're in moles, and we're going here. So we have to use this for our X line. 1 mole is what you see first. So that goes on the bottom. And you'll notice that you want that, so it'll cancel. You can't just write 1 mole, though. You have to write 1 mole of potassium oxide, because you always have to write NUF, number, unit, formula. Within your unit converter for anything on a road in Moleville, you'll always have the same substance on the top and bottom. So this is for 94.2 grams of potassium oxide. I got that from the molar mass. See, my Moleville map says molar mass, but I have to solve for that before. All right, things that can cancel, mole of potassium oxide. And then we have 6.3 times 94.2. That's going to give us 593 grams of potassium oxide. Let's do one more. How many moles are in a 4.8 gram sample of phosphorus tribromide? All right, how many moles is the question, and you have 4.8 grams. So you currently have grams. You're hanging out at a house at mass mansions, and you're going to moles. So here's moles, and here's the direction I'm going to take on the road. I'm going from the mass mansions to Mole City Hall. Again, the first things first is we have to figure out the formula for this. So I noticed that there is a prefix, tribromide, and that tells me that this is covalent. We have a molecule here. And when you have a molecule, it actually tells you how many in the formula. So phosphorus doesn't have a prefix, so there's just one P. Tri means 3, so 3 bromines. PBr3. What's the mass of this? Well, you're going to plug in your masses from the periodic table. When you add these up in your calculator, you're going to get 207.7 grams. So let's do our stoichiometry now. Always write your known first, 4.8 grams of phosphorus tribromide. X line, and then what goes on the bottom is what you hit first, the molar mass. We already solved for that, so 270.7 grams goes on the bottom. And don't forget your formula, phosphorus tribromide, or PBr3. On the top would be what you see next, 1 mole of PBr3. Cancel out what can cancel. Multiply anything on the top, 4.8 times 1, divide by anything on the bottom, 270.7, and that gets you 0.018 moles of PBr3, or phosphorus tribromide. All right, best of luck with your worksheet.